All right, in this problem sum smart card sheets, you can see we follow a method which is called use what you see. Yeah, so a lot of times for a problem sum, you can actually just follow the keywords by reading in an organized way from left to right, from the first line to the last line. Then you just follow step by step. Yeah, so your working line actually correspond to the sentences, which really means that working step one will somehow follow line one or line two. Yeah, sometimes line one is just like the start of the story, like an introduction. Yeah, so probably start off from line two. Then your other working steps actually start off will continue from the subsequent sentences. Okay, so here goes. Okay, what do you have to remember when you first see a problem sum? If you are using a pen and no highlighter is used in this case, and then it actually makes the whole solving process easier and also neater and hassle-free. You use one single pen, be it black or blue, and then you underline the keyword, then circle the numbers. Yeah, if that keyword is like a more important keyword, like a concept keyword, like remainder or remaining for remainder concept, or at first for working backwards, or the name is a repeated name for question with repeated identity, you double underline. Okay. Okay, so when you see a number, do not freak out. When you have more numbers, the better it is, because the numbers are able to help you to understand as well as to solve the questions. So generally, the number is for you to find one unit. Okay, so moving on, when you have to draw a model, for example, when you see keywords like more, less than, more than, less than, or equal, then make sure that you draw the model. And when you draw the model, you also want to make sure that it's complete and it's not half drawn or a quarterly drawn. You want to put in the names or the identities, and then with the numbers and as well as the question mark to direct you where you need to find the answer, or what answer do you need to find. Okay, so in this little box here, we call it the Mr. Number and North Star. What is North Star? North Star generally is like a 1U, and 1U is something that you must find for most problem sum. Once you actually use units in problem sum, you know that you have to find the value of 1U. And this is somehow like a guarding lights for your child whenever he is lost. So whenever you have to find the value of 1U, the number given in the question is generally used to find the value of 1U. So for example, let's say you have figured out and then that 2U is equals to the given number. To find 1U, you have to take the given number divided by 2. All right. Okay, so right now I'm going to go through the different types of problem sums. First of all, when you see 2if, what is 2if? There are 2if in the question, and they will start off like, for example, if 8 cans is given to each family, and then they will have like 64 cans left or short of 64 cans. Yeah, and short of has the same meaning as need some more. Yeah, then in the next sentence, it is the same sentence structure. If then some given to each family, then you have left or short of or need some more. Yeah. So for LB kids, they have learned that when you see both sentences ending off with left or need some more or short of, it's a minus for step 2, because in step 1 is total needed for the change. Step 2 is small difference, and then step 3 is total needed divided by the small difference. Okay, yeah, so this minus is actually for step 2 for the small difference, but when you have left and need some more slash short of, you need to plus. Okay, you need to plus. All right. Okay, maybe I just quickly add it inside here. Yeah, so okay, so step 1, okay, we have total needed for the change to happen. Okay, so step 2 we have SD, small difference, and this is actually for step 2. Yeah, it will affect whether it's a plus or minus. So step 3 will be step 1 divided by step 2. Okay? Okay. Then next you have equal concept. So we have equal before change or equal after change. And when you see the word equal, make sure that you draw 2 equal boxes or 2 KitKats. Then for the equal fractions, you make use of this method called the tic-tac-toe. And what is equal fractions? For example, half of John's marbles is equals to, say, 2/3 of Peter's marbles. So when you see two fractions on the left and the right side of equal, this is called equal fractions. And then you have to make use of the method called tic-tac-toe, which simply means you have to make the numerators the same. And when you see the word u inside the equal, is to make up the same. Okay? Yeah. Okay. So next, for the fraction of total, for some questions which are very straightforward, and then they give you like a fraction of it, fraction of the total, fraction of it again, and you realize that the it and the total is they are referring to the same thing. So make sure that in this case you just add or minus or respectively, and then you make sure that the denominators are made the same before you add them together. Okay, so if they're asking for mixed numbers, make sure that you give them in mixed numbers. If they're asking for improper fractions, make sure that you give them in improper fractions. Okay, so what about fraction with units? Okay, in some cases, for example, John has half kg of the cake given by his mother, and then he ate 1/3 of it. Yeah. So in most cases, under time pressure or exam stress, some children may misunderstand them and take one fraction minus the other fraction. But in this case, one fraction has units which is in kg, and the other one has a fraction which is of it, and they do not mean the same thing. So in this case, for example, okay, so pardon me for trying my best to draw the chicken. Yeah, this is the best I can draw. And for example, this case, okay, it's different thing, right? Okay, yeah. This is just to illustrate that half of the chicken is actually not half kg of the chicken. Okay, so let's say I have a 3 kg cake, and then half kg is sold, and then half of it is given away. Right, so some children may just take 3 minus half again to find the answer, to find what's left. Yeah, a very common mistake made. Yeah, so take note that this off, right, is actually times, and this is actually referring to the whole thing, the one whole, which is 3 kg over here. Okay, can? Okay, so back to okay, moving on, guess and check. Actually, there are 4 steps, and generally they have a few things to check. Okay, so first of all, there's no PRF, percentage fraction ratio fraction. There's no like equal. There's no more less than. There's no like a 4 times as many as okay. There's no every, because when you see the word every, it's grouping. So which means that the keyword here is every. All right. Okay, so for guess and check, you assume all opposite means the opposite of what you need to find. So example, if they have horses and ducks, you want to find ducks, right? You assume all are horses. Then we have the big difference, which is the difference between the assumed total and the actual total. Small difference, which is the difference between one of each. And then the big difference will be, the step 4 will be big D over small d. Okay. All right. So moving on. Okay. So let's say for some questions which is like marks deducted for wrong answers. Okay, this one will be a plus instead of minus. Okay, just be careful huh? Yeah. So grouping wise, the keyword will be grouping. It will be every. So when you see the word every in a question, it's actually grouping, and then it will be under find one group. It can be solved using 3 steps. So it is actually step 1, find one group. when I teach the children, I actually invited them to watch Dora, just a story. And then for step 2 is to go to GV. GV is going to be to watch Dora, and then that one is actually to find the group value, and step 3 is actually number of groups. So in this case, to add on, group value actually got 2, 1, and 2. Sometimes it can be in terms of the number of items in the group. Sometimes it can be the value as well. For example, let's say you have 4 $1 coins and 1 50-cent coin. So the 5 coins can be one group value. At the same time, the money, the value in terms of the dollar value is also another group value. Okay. Then for number of groups, you have the total value, which is normally given, divided by the group value. Okay. For step 3. Okay, for more or less, then when you see the word, immediately draw model, either like a step model, long, short, or short, long. Part, whole, then you do as per normal. Then for part, whole wise, normally is, I call it the MRT trains, whereby you have to connect boxes together. Okay. Then for percentages and numbers, take notes that it's an arrow, not equal. It's like 20% is equivalent to 100 pence. So when you want to find 100%, right, you can times 5 instead of finding 1%. Then generally what I teach the children is when you see percentage and numbers, and children some of the kids told me that they are terrified by the percentages because it's actually very hard to solve in their own opinion. Yeah, so I told them that when you see a number and percentages, right, you work on the number. Yeah, so you get a number out first, and the percentage is actually on the number itself. Yeah, and normally percentages is like you have like 80% of say $300. The off is actually like times. It's actually times in maths. Okay. So number first, then the percentage applies on the number. Okay, repeated identity ROI is when one of the identities is repeated. So in this case, B is repeated. So there's a sentence which is like A is to B, then next sentence is B to C. Then you make B the same because they are repeated. Because B is repeated twice. For P5 and 6, generally I don't recommend model drawing because it's very slow, and they should be able to use ratio to solve. Then in another repeated identity type 2, whereby in this case A is repeated, and then normally B is like, they will say B is like 3 times as many as C, so you have to draw model. Okay. Yeah, and then the difference is 2U, and then you use the numbers again, which is the number to find your North Star. Yeah, so back to this, actually this rule is very important for you to remember. Okay, number to find 1U, to find your North Star. Yeah, what are the numbers for in the question? To find your North Star, to find 1U, numbers to find 1U, numbers to find 1U, and numbers to find 1U. Okay, actually it's one number to find 1U generally. Okay, so remainder concept wise, you will have 3 faces. You have the smiley face, you have the blare, like when someone stick out the tongue, they go blare, yeah, blare, blare, blare. And then you get the gong gong. Gong gong is like in my own world, when I was young, sometimes my parents say I'm gong gong, like blah blah like that. Yeah. Okay. So if you want to do like pull down, right, the top will be the smiley faces, and then the bottom you will be the blare, the P. And then normally they will have question mark here, okay, to guide you along. So normally such question, right, they will have like maybe 10 over here, then you work upwards. Yeah. Then the other one is just a side note here. Plus say 2 more. So fraction plus 2 more. Method will be pull down, okay? Yeah. Then okay, or maybe I should write at the bottom lah, huh? Yeah, okay. So if let's say they say half and 2 more is a pull down. Yeah, it's a pull down. Then what you see here is branching. Then if they say what's that? Top up, okay, top up to the initial amount is actually branching. Okay. Right. So you need to be able to know both to survive your physics journey. Okay, so same difference wise will be the equal change. Yeah, like plus 10 for both or minus 2 for both. Yeah, for both. Okay, for both. It's like same number. For example, 2 girls and 2 boys left the classroom. 10 marbles are given to Jane and 10 marbles are given to Peter. Then equal change. These are the keywords. So normally what you want to do is you want to add or cut in front. Don't cut at the back because it's very hard to see. Okay, and because by doing this, you can actually have the same difference not affected at the back because all the cutting or the adding is done in front. So let's say you have ratio, right? Make sure that the difference is the same. Okay, and then of course the age question is quite common because of the same difference. The difference will never change because if like next year my age will +1, your age will +1 as well. Last year my age -1, your age also -1. Okay. Okay, so moving on, same one. Then let's say there's A and B, use ratio, and then B unchanged, you have to make B the same. Same total, you have to make sure that you have the total, and then make the total the same, and then make sure that knowing that the drop will be equals to the rise. So let's say -10 from A, it's actually +10 from for B. If it's -2U for A, for A, you'll be +2U for B. Okay, so it must be the same. And this is one way to track. Okay, another thing to take note is when you are doing ratio, right, eventually you have another as in the eyes of kids, like the real ratio. Okay, yeah, so normally there are 2 rows under before and then 2 rows under after when you make the 2 numbers the same. Okay. Okay, last one will be, for the last page, it will be simultaneous, right? Okay, simultaneous wise is very straightforward. So for example, they have like a 1 chair plus 1 table cost so much, 2 chairs plus 1 table cost so much. Okay, so the numbers are the same. I mean, the numbers are different, 2 objects, and then 2 different values. So this is the 222. This is the 222. 2 objects, okay, 2 objects, 2 numbers, and 2 values. 2 values. This is the value, okay, the two values. Then the other very common grade 5 and 6 simultaneous type 2 will be, they will give you 2 objects as well, but instead of numbers, they give you fractions. And they give you 2 values. Okay, for example, total there are 40 oranges and pears, and then they say half of, okay, apples and oranges. So half of the apples and 3/4 of the oranges are sold. Okay, are sold. Then left, we will have another number which is say maybe 10. Yeah, so that's when you have to draw the model because of these 2, and then you have to draw 3/4, right? So you have you have 4 O's. Yeah, so same thing. 2A plus 4O to give you 40. And then 1A left and right plus 1O. Yeah, 1O to give you 10. Something like that. Yeah, so end up you'll go back to these two as well. Okay, so you're able to solve simultaneous like that. Okay, units and parts wise, actually is also riding on simultaneous because when you have, okay, maybe we cover how they look like. So in the question, it's very clear. You have before ratio, and then there's this external change, and then there's this after ratio, and then you have to use the HDB flat. Okay, you have to use the HDB flat to start to do, and then you have the two objects. Okay, object 1, object 2. Then you have the before ratio, after ratio, and then the change will be, if it's a like addition, more added, you have a plus, taken out will be minus. Yeah, so plus minus okay, then you have two equations. Two equations wise will be top down. Okay, one, then the other one here will be 2. Okay, so you have to draw model. Don't use algebra to solve. Then find one U, and then you take the original one to find the actual answer. Because the equations are actually expanded to solve. Okay, and of course the top will have units, and the bottom is parts, make parts, and you make parts the same. Okay, yeah, so by making parts the same, you have two new equations, and those are created, and they are not the original ones. Okay, unlike same one, same total, same difference, you have to take the orange lines because those are the actual one whereby the unchanged is made the same, the total is made the same, and the difference is made the same. Okay, can? Okay, and of course, by knowing this one is actually simultaneous equations. Some kids are taught to use algebra at home, and if they understood, fine. If they don't, use model to draw. All right. Okay, so last two, for example, you see like 4 times as many as, 5 times as many as. This is grouping. Why? Because let's say in a question, A is 4 times as many as B. All right. So what you have here is in a group, you actually have 4A and 1B, and 1B, and then you have many groups, and there are 5 of them, and then you have the total value. All right. So same thing. Step 1, find one group. Step 2, group value, there are 2. Step 3, number of groups, you have total value divided by group value. And then that will give you most of the steps, and then you have to move on to find out what they want. And in this case, 18 is the same as 7, okay, over here. So it's the same thing. Okay, next, last one, working backwards. For working backwards questions, generally they are very long, and then but the structures is about the same, are the same. So line 1 or line 2, they will talk about the change 1. Then line 2, they'll talk about the change 2. And then line 3, they'll be asking, oh, so what is at first? So this is a keyword to identify that it's working backwards. Then how do you start? Because it's very confusing. Then you choose the sentence just before the question sentence to start off. Then you solve backwards. Okay, then you solve backwards. Okay, the other trick is if there is internal transfer, if there is, you can actually make total the same. Okay, so this is another trick. Yeah, instead of trying to minus or plus, you know that since the total is always the same, right? You can create a table. You can create a table. So you have a example. Then this is you go back. So this is the final, this is the end, right? Then this is the change 1, this is the change 2. Okay, so looking at it, you need to have a before. Yeah, sometimes you just need 3 rows. Then this one will be the total. So you have to make total the same. And then maybe this one will have like quantity for A, quantity for B. And then no matter what you do, right, sometimes you need to work backwards by reversing the change. But knowing the total, sometimes you can just take, if you know A, right, you can take total minus of B, okay? Sorry, okay, let me repeat. Let's say if you know A, right, to find B, instead of reversing the change, you can just take total minus A. Then later when you know B, right, take total, which is supposed to be the same as here, minus B to find A. Yeah, then to check whether your A and B are correct, sometimes they ask for A at first. Make sure that whatever you have here, you add together, it's the same total. So this is also like a check itself. Okay. So I hope that by now you should have a better understanding of this, and do not only watch this video once, watch it like many times, watch it once every day until PSLE, and then you'll be very clear on how to start. And this is actually give you an edge in over others in solving questions fast, because a lot of times for kids, I feel that sometimes it's not because their maths is bad, it's because they don't know how to start. And that's why they are stuck right at the first door. Yeah, so by going through all this, right, actually helps the children to open up the first door and then gain momentum and then able to solve the questions correctly. And then this is how they actually start to gain more and more marks as well as confidence also. So this is why we actually call this the problem sum smart cards. You literally use what you see, and then you just do accordingly. Okay, so thanks so much for watching, and then wish you all the best, and watch it again. Yeah, don't just watch it once. Okay, take care.